What is deductive reasoning? Let's examine what it is, how to properly execute it, and how it applies in the world of knowledge making. Detective? That'll work for now. Detectives are one of the many knowledge makers in their respective fields that use deductive reasoning in an attempt to come to a specific conclusion from the concordance of multiple true premises. But let's get into what reasoning actually is. Reasoning is a way of knowledge that allows the creation of new knowledge through the synthesis of old information, through thinking and by the process of reflection. This is otherwise known as the rationalist approach. Sometimes, deductive reasoning is as simple as a syllogism. Let's say that a murder occurred at a large mansion, but there were only two people in the house, the victim and another individual. Through deductive reasoning, we can assume that the murderer is the individual who is alive. This is only true if the premises are absolutely true. If there really was only one other person, then logically, the murderer has to be the person alive. As long as the premises are absolutely true and the logic was valid, then we can say with confidence that the conclusion is absolutely certain. Deductive reasoning contrasts its counterpart, inductive reasoning, because inductive reasoning does not involve any degree of certainty. Inductive reasoning applies knowledge from specific instances and generalizes them. This method in itself is known as the problem of inductive reasoning. For instance, I have generalized that mammals tend to give birth to live babies, but then I learned about the platypus. Although my claims are supported by multiple pieces of supporting evidence, such as cows, pigs, humans, and dolphins, there are instances that contradict my point, such as the platypus. This is the most common issue in regards to inductive reasoning, using our specific instances to generalize knowledge. The human tendency to search for patterns, even when they are not there, lead to inaccurate conclusions and quick generalizations that aren't necessarily founded on a solid ground of evidence. This faulty in inductive reasoning may be one of the main reasons that deductive reasoning is so valued. It has the ability to ascertain absolute certainty. But this process must be executed carefully. We reviewed the importance of the truth of a premise, but what about the validity of the logic used to come to a conclusion? Let's see what's wrong with this reasoning. Children are scared of clowns. There are no clowns at a haunted house. Therefore, the children will not be scared at the haunted house. There's an obvious issue with this argument, but can we figure out what? Venn diagrams are a good visual aid to assess the validity of the logic used in syllogism. The circles represent sets of claims: children, the things they're afraid of, and clowns and haunted houses. Children are obviously not only scared by one thing, but multiple. Also, some children may not even be scared of clowns or haunted houses. The premises and logic used are both invalid and result in untrue conclusions. This issue regarding the validity of logic leads us to the topic of fallacies, which are errors in formal reasoning. For deductive reasoning to function properly, we have to have a true premise and valid logic. Fallacies can interrupt the validity of logic, and it is important to make note of their existence to avoid them. As a quick introduction to fallacies, we'll be taking the hasty generalization and appeal to common practice fallacies into consideration. Hasty generalization is making an assumption about an entire group based on a sample that is inadequate or insufficient due to a sample size, or because of the sample's atypical nature. For instance, stereotypes about people fit into the category of hasty generalizations. Let's say that square-headed people are believed to be liars and thieves, and even though this premise is incorrect, someone may choose to believe this premise. They may falsely accuse a square-headed individual of theft. All square-headed people are liars and thieves. Therefore, even though I do not have any evidence, the square-headed person must be the jewel thief. Appeal to common practice is an attempt to validate a certain premise by stating that a majority of individuals condone or practice a certain action or mindset. This fallacy is comparable to truth by consensus, which we all know is not a valid truth test. Listen to your parents on this one. If your friends jumped off a bridge, would you too? Appeal to common practice lacks reliability. How valued is society's thoughts, and how are they reliable? These questions that arise show glaringly obvious pitfalls in the logic and validity of premises based on appeal to common practice. Now that we have a general understanding of how to execute deductive reasoning, and we're aware of the pitfalls we must avoid, we can analyze the importance and application of deductive reasoning in knowledge-making. As stated before, deductive reasoning that is executed properly with a true premise and valid reasoning can result in absolute truth. Other than detectives, what other knowledge makers use deductive reasoning? Let's examine the role of deductive reasoning in mathematics and the potential for absolute certainty. We stated before that valid deductive reasoning requires true premises, but how can we verify that the premises of mathematics is true? Easy. People just made it up. The premises used in mathematics are the Hindu-Arabic numerical system and the symbols for mathematical functions. People define these systems and used and understand the value and processes that are related to the numbers and systems. And so long as human error is not involved, mathematics is the perfect example of deductive reasoning used properly. Well, we can check true premises off our list. Now, let's move on to valid logic. How do we know that each mathematical formula has valid logic? Have you ever heard of PEMDAS? If you haven't, it's an acronym for Dictated Method of Approaching a Mathematical Equation. Complete anything within the parentheses, exponents, multiply or divide, and then add or subtract, going from left to right. You may have seen any social media posts asking if the answer is one or another. For example, this post from Instagram. Now, if everyone remembered PEMDAS, the answer should be 2, because mathematical equations have a rule of thumb to follow. Each knowledge maker in mathematics is able to follow along and check if the logic used is valid. Let's wrap everything up into key points. Deductive reasoning is coming to a specific conclusion from general premises. 2. To properly execute deductive reasoning, you must have a true premise and valid logic. 3. You must be sure to avoid any logical fallacies to ensure clarity. 4. For deductive reasoning has the potential to reach absolute certainty, but does not always reach it because finding absolute truth in the premises may not always be so simple. So, be careful and be aware of all the pitfalls.